all, objective of this chapter. Basically, the objective of this chapter are to understand forces working on a flight, principal axis and rotation of aerial systems, stable, unstable and neutral systems, control, how to move your drone, roll, pitch and yaw. So let's start with the forces of flight. Every particle in the universe is subjected to force. Each particle attempts to reach its stable position by balancing out various forces acting on it. In case of flight, there are four such forces as follows: weight, lift, thrust and drag. So if we will talk about weight, then weight is the force of gravity. It acts in a downward direction toward the center of the earth. Lift is the force that acts at a right angle to the direction of motion through the air. Lift is created by differences in air pressure above and below the wings of airplanes. Thrust is the force that moves the flying machine in the direction of motion. Engine produces thrust with the help of propeller, jet engine or rocket. Drag is the force that acts opposite to the direction of motion. Drag tends to slow down the flying machine. It is caused by friction and difference in air pressure. So, basically, here you can see the forces acting on airplane. So basically, lift, drag, thrust and weight. So let's start with the principal axis and rotation of aerial systems. An aircraft's flight is free to rotate in 3 dimensions of space. These rotations are produced by moment, torque about the principal axis. These rotations are intentionally produced by moving control surface of an aircraft. This results in variation on net force, enabling the user to maneuver the aircraft. They are explained as follows. So basically, this is perpendicular axis, longitudinal axis and lateral or transverse axis. So let's start with the perpendicular axis. Basically, perpendicular axis is denoted by the green line. So green line shows the perpendicular axis. Blue line shows the longitudinal axis and red line shows the lateral or transverse axis. So by the help of longitudinal axis, we are controlling the roll motion of airplane, and pitch is controlled by the lateral or transverse axis and yaw is controlled by the perpendicular axis. So the question is, what is longitudinal axis? The axis along the length of the aircraft using passing through its center of gravity. The rotation of the aircraft along the longitudinal axis is called as roll. This is caused by moving the aileron. So here you can see the longitudinal axis and roll motion of airplane. Next, lateral or transverse axis. Basically, the axis that runs below the wing from one wingtip to another, passing through the airplane's center of gravity. The rotation of the aircraft along the lateral axis is called as pitch. This is caused by moving elevators. Another one is perpendicular axis. So the axis perpendicular to the wing and body of the aircraft passing through the airplane's center of gravity. The rotation of the aircraft along the perpendicular axis is called as yaw. This is caused by moving rudder. So you can see this is rudder and yaw is caused by this and this. So the question is, what is equilibrium? What is equilibrium? Any body or object always experiences a number of forces from various directions. When the resultant of all these forces acting on the body is zero, the body will remain in the state of equilibrium. When, due to a small change in the acting forces, the body will shift away from the state of equilibrium. So again, we will study about stability. So what is stability? When a body experiences unequal external force, it is displaced from its original position. This displacement could be in terms of position, inclination, or a combination of both. Depending on the behavior of the body, it can be either of the three types of systems. Number 1, stable system, unstable system, and neutrally stable system. So let's start with the stable system. If the body returns to its original position after being displaced, it is said to be a stable system. For example, when you push a swing in the garden, the swing will return to its original position after a few oscillations. Such a system is called as stable system. So here you can see the difference between stable and unstable aircrafts. Now the question is, what is unstable system? If the body does not return to its original position after being displaced, it is said to be an unstable system. For example, if you balance a pen on its tip on a table, it will start to tilt downward by the slightest application of external force, and it will keep on tilting until it completely falls down. The body does not return to its original position but keeps on moving further away. Such a system is an unstable system, and here the diagram shows the unstable system. The neutrally stable system. If the body does not return to its original position and does not even keep on moving away from it, but stays in the new position, it is said to be neutrally stable system. For example, keep a spherical ball on a horizontal table. Move it by your hand to a new position and leave it. The ball will now either return to its original position nor will it move further. It will stay in this new position. Such a system is called as neutrally stable system. A drone without any sensors cubed in a neutrally stable system. When a drone is dropped from a height without applying any forces, the angle at which it is dropped will remain same till it touches the ground. Hence, neither the angle goes back to its original inclination nor does it deviate further but remains same. It is interesting to know that stability is measured with respect to a certain parameter. Like in the case of a drone falling from a height, it is a neutrally stable system when it comes to the angle. However, if you consider the position of the drone, then it becomes an unstable system. Multirotors are neutrally stable system which is stabilized with the help of sensors, microcontrollers and motors. Thus, if one is to drop quadrotor without arming, it would fall in the same orientation as it was left in. Assuming that we apply no torque on the drone while dropping it. In order to take care of the inherent neutral stability of the drone, it's necessary to use sensors and control its behavior. Note that it is extremely difficult to fly a drone without sensors, but an aircraft can be. Thus, control of drone is a very important aspect. A user controls the drone via wireless remote control hardware over radio or Bluetooth. Here is how it works. So basically, there are three controls in aircraft or drone. Number 1 is pitch, yaw and roll. So by the help of this diagram, you are now able to define the controls. This shows yaw. This line shows the roll motion, this pitch and this yaw. So let's start with RC joystick control diagram. Basically, this is the joystick control diagram through which we can control our drone. So basically, two sticks are there. First is used for throttle, up and down, your left and your right. Another is used to pitch up and roll. So this shows pitch down, pitch up, left and right. What is roll? Roll done by pushing the right joystick to the left or right. Literally, roll the quad rotor which maneuvers the quad rotor left or right. So let's start with the working principle. Basically, here you can see the rolling motion of drone. When you will push the left, then the drone will move like this, and right, the drone will move like this. Working principle of roll. For a quadcopter or for a quad rotor to roll, it needs a torque about the center of gravity along lengthwise front-back directions. To roll the quad rotor toward the left, we need a counterclockwise torque. That means the thrust on the right pair of rotors should be more than the thrust on the left pair of rotors. This is attained by increasing the speed of pair of rotors on the right to create more thrust on the right side as measured to the left side, and the required torque is generated. Similarly, increasing the speed of left pair of rotors creates more thrust on the left side as compared to the right side, and quad rotor rolls the right with this torque. After rolling the drone on either side, the thrust on the rotors generates a lateral force which then translates to the acceleration moving the quad rotor to left and right. This diagram shows the motion of pitch. So what is pitch? Pitch is done by pushing the right joystick up or down, tilts the quad rotor which maneuvers the quad rotor forward or backward. This is the working principle of pitch, which is explained in this diagram. Working principle of pitch. For the quad rotor to move along with direction, in this case forward or backward, we need to generate torque. Thus, to perform a pitch movement, it needs to generate torque at the center of gravity along the lateral axis. To facilitate forward movement, rotors at the back of the drone need to provide additional torque. This requires the respective motors to provide more force by running the back motors at extra speed. Similarly, for backward movement, the forward motors need to run at extra speed. Yaw. It is done by pushing the left joystick to the right or to the right. Rotates the quad rotor left or right. Orient the front of the drone in different directions and helps with changing directions with flying. So this is the yawing motion. Working principle of yaw. Unlike roll and pitch, yaw is the effect of the rotor on the frame of quad rotor. When a propeller turns clockwise, it generates counterclockwise torque on the frame to equalize the torques. Diagonally opposite rotors generate torque in the same direction, clockwise or counterclockwise, anticlockwise. If one of the pair of diagonally opposite rotors generate more torque than the other pair, then the frame will have a resultant torque acting in on the direction. This helps the quad rotor to yaw. Throttle. To increase, push the left joystick up. To decrease, pull the left stick down. This adjusts the altitude or height of the quad rotor. Working principle of throttle. Throttle up down basically means controlling the quad rotor to go higher lower. Throttle up is achieved by increasing the speed of all rotors at the same time and vice versa for throttle down. This causes propeller to increase the thrust generated that help the drone go higher. Thank you. We will meet in another lecture with more detail.